Today we're going to talk about equivalent ratios. Let's do a quick review between what a ratio is and a ratio relationship. Remember, a ratio is simply two numbers that are being compared, whereas a ratio relationship uses words to describe the relationship between the two amounts that are being compared. Take a moment right now and write one sentence that describes a ratio using a ratio relationship. Here's one. The ratio of the number of sunny days to the number of cloudy days in this town is 3:1. Now, take the ratio out of the ratio relationship and write it in two different forms. So for example, my ratio relationship, I can extract the ratio 3:1 and I can write it 3:1, or using words 3:1, or numerals and words 3:1. Okay, Shawnee and Mel are using ribbon to decorate their school project. The ratio of the length of Shawnee's ribbon to the length of Mel's ribbon is 7:3. Let's make a table so we can put down all of our information about Shawnee and Mel's ribbon in one place. Okay, if we know that the ratio of the length of Shawnee's ribbon to the length of Mel's is 7:3, then we can put 7 in the length of Shawnee's and 3 in the length of Mel's. But we can also do this using a tape diagram if we wanted to. Here's Shawnee and Mel. Here are Shawnee's 7 units of length, and here are Mel's 3 units of length. Notice I used the word unit. That's because, well, were we told what each unit was actually worth? The ratio of the length of Shawnee's ribbon to the length of Mel's ribbon is 7:3. Well, that's great, but 7 what? 3 what? Let's assume for a moment that they're talking about inches. So, how many inches is Shawnee's length and how many inches is Mel's? Well, of course, if we have 7 units and each one is worth an inch, for Shawnee, she has 7 inches total. And if we were to do the same with Mel, where each unit is worth 1 inch, we'd see that Mel has a total length of 3 inches. And what do you know, this matches with our T-chart, the length of Shawnee's ribbon being 7 and the length of Mel's being 3. But what if the units weren't 1 inch each? What if they were worth 2 meters each? In that case, into every unit we would plug 2 meters, just like this. And so to find Shawnee's length, we would simply add up all those 2's. Or, seeing that we have 7 groups of 2, that's 7 times 2, which is 14 meters. We do the same with Mel. He has 3 units. Each unit has 2. That's 3 groups of 2, which is 6 meters. Going back to our table, we can now add our new data. If the length of Shawnee's ribbon is 14 meters, then the length of Mel's ribbon has to be 6. So looking at this table, what is the ratio being shown here? Is the ratio 7:3, or is it 14:6, or is it both, or either? Let's look again at our tape diagram. Notice the amount of units that we have. Shawnee has 7 units and Mel has 3. When we plugged in 1 inch in each, we still have 7 units and 3 units. When we plugged in 2 meters into each, we still have 7 units and 3 units. It's just that each unit has a different value. So again, which is it? 7:3 or 14:6? Well, actually, it's fine to say either. Again, plugging in any amount into each of these units is going to make them grow exponentially. We might have 7:3 if there's only 1 in each, or 14:6 if there's 2 in each. What if there's 3 in each unit? The number will grow, but we will always have those 7 units to 3 units, won't we? Let's try it. Let's plug in 3 inches for each unit. If that's the case, what will Shawnee's length be? 7 units, 3 in each. That gives us 7 groups of 3, which is 21. And Mel has 3 units, and each is worth 3, so that's 3 groups of 3, which is 9. Let's record our data back in our table. And now we can put that if Shawnee's ribbon is 21 inches, then Mel's has to be 9. And so, again, what's our ratio here? Is it 7:3, or is it 14:6, or possibly 21:9? Okay, our original ratio was 7 units to 3 units. We plugged in 1 for each, and we ended up with 7:3 again. We still had those 7:3 units, and this time we plugged in 2, and we found that we had 14:6, but it's still 7:3 units. And lastly, we took our 7:3 units and we made each unit worth 3 inches. We found out we had 21:9, but it's still 7:3 units. So you see, no matter what we plug into these units, our original ratio of 7:3 remains the same. Here's a problem. Mason and Laney run long distances to train for their race. The ratio of the number of laps that Mason ran to the number that Laney ran is 2 to 3. If Mason ran 4 laps then, how many did Laney run? Alright, let's start putting down our data. We have Mason and we have Laney. And we have a ratio, 2 to every 3. So we can put 2 units for Mason and 3 for Laney. But we're also told that Mason ran 4 laps. The question is, if Mason ran 4 laps, then how much is each of these units worth? Well, I can take 4 and split it into 2, can you? Of course, Mason's units are going to be worth 2 laps each, because that will give us a total of 4 laps, which we are told that he ran. Now this is going to make the problem nice and easy for us, because now that we know that each unit is worth 2, we simply plug in 2 to every other unit. And we can add up 2 plus 2 plus 2 for Laney, or just multiply 3 groups of 2 and find that he ran 6 laps. Okay, let's use the same ratio, 2 to 3, but if Laney ran 930 meters, how far did Mason run? We have our same ratio, 2 to 3, but this time, we are told that Laney ran 930 meters. We have 3 units. Can we split 930 into those 3 units? You bet. 930 divided by 3 is 310. Each unit is worth 310. This makes the rest of our problem nice and easy. Because if each unit is 310, then Mason's units are also worth 310. And altogether, we can find out what Mason ran. If Laney ran 930 meters, then according to our ratio, Mason must have run 620 meters. Okay, Josie takes a long end-of-the-year vocabulary test. Later, Josie finds out that the ratio of problems she got incorrect to those she got correct on the test was 2 to 9. If Josie missed 8 problems, then how many did she get correct according to our ratio? Okay, let's use tape diagrams again. We have incorrect and correct problems. And we're told that the ratio of incorrect to correct problems is 2 to 9, so we can put those units in. 2 incorrect for every 9 correct. There they are. Also being told that she's missed 8 problems, we can put that data in. And now we can label our incorrect total as 8, because that's what we are told that she missed in all. Now that we know that the incorrect total was 8, and we can see that she has 2 units, we can split those 8 incorrect into 2 units, and find that there are 4 in each unit. And again, this helps us for the rest of the problem, because now knowing that each unit is worth 4, we can plug that in for every other unit. So to find out the total of correct, we can add up 4 9 times, or we can just say, hey, 9 groups of 4 is the same as saying 9 times 4, which is 36. So, really quickly again, we knew that the ratio of incorrect to correct was 2 to 9. We made a tape diagram to show these. We were told that she missed a total of 8, and so we labeled the total of incorrect as 8. And then we split that total into its correct units, finding that each unit is worth 4. Then we plugged it in everywhere else and found that the total correct that Josie got was 36, according to the ratio 2 to 9. But what if Josie found out that actually she missed 10 problems? Well, the ratio hasn't changed. It's still 2 incorrect for every 6 that are correct. And so we can label the total of incorrect this time to be 10. And what is 10 split into these 2 units? 5. Now we know that for every other unit, it must also be 5 as well. And to find the total correct, we see that we have 9 groups of 5, which is equal to 45. This time, Josie got 45 correct. Now that we've done this a couple of times, what ratios are equivalent to 2 to 9? Well, here is the ratio 2 to 9, and here again is 2 units to 9 units. But we see that it's also equal to 8 to 36. So 8 to 36 is equivalent to 2 to 9. And yet, here is also 2 units to 9 units. But this time, the totals are 10 to 45, so that must be equivalent also. Here are all 3 ratios, and now we can say that all of these ratios are equivalent. They will all fit into the same 2 units to 9 units ratio. By the way, did you notice a pattern between these 3? Well, to go from 2 to 9 ratio to 8 to 36 ratio, we could simply quadruple or have 4 times as many. And notice that's what we did. Here are our 2 units to 9 units, but the value inside each unit is 4 times as much as 1. So this is 4 times as much as 2 to 9. And what about going from the 2 to 9 ratio to the 10 to 45 ratio? The units were worth 5. So 10 to 45 is 5 times as much as 2 to 9. 5 groups of 2 to 9 will give us a 10 to 45 ratio. Wow, we have worked on a lot today. First, we learned that we can use different tools like tables and tape diagrams to visualize ratios. Secondly, in using tape diagrams, we were able to see the value of each unit of our ratio. And lastly, we were able to see that ratios can have equivalent ratios or equal ratios as long as the basic number of units is the same. 2 to 9, 2 to 9. The values are different, but the ratio of 2 units to 9 units remains the same. Thus, they are equivalent.